Hello, I'm Mensa Augustine. In this lesson, we are going to solve this simple question on the board. Join me as we go through it step by step. Now, we have to show that the points A, B, and C form the vertices of a right angle triangle. We are going to solve it using two methods. Now, let's see the first method. If you have a line, then the length of the line is given by this. So let's say the length of the line AB. So the length of line AB equals x1 minus x2 squared plus y1 minus y2 squared, where these are the coordinates of A and B. So you understand the coordinates as we move on. So if I take AB, then this is what I'm going to write. The square root of, let's take the points A, minus 1 minus 3, then the point B is 6 and 1. So these are the coordinates. The coordinates of A are -1, -3. The coordinates of B are 6 and 1. So I name here x1, y1, x2, y2. Or you can name here x1, y1, x2, y2. So if I take the x coordinates of -1 minus 6, then I square it plus, if I take the y coordinates of -3 minus 1, then I square. So if I square this, I'll get 49. If I square this, I'll get 16. So if I add 49 to 16, I'll get square root of 65. Kindly check with your calculator. So on the calculator, you point into bracket -1 minus 6, you close and you square. You get here to be 49. If you do 1, 2, you get 16. If you add, you get 65. Then let's do for BC. So C, 2, -5. So let me clean this off. So once we are on BC, we name here x1, y1. Let me bring C here. X2, y2. So we take the x coordinates, 6 minus 2. Then we square. Plus, we take this one, 1 minus 5. Then we square. So if we square this one, we are going to get 16. If we square this one, we are going to get 36. So if we add it together, we are going to get 52. So this will give us square root of 52. Kindly use your calculator to check. Now, we take AC under the square roots. Wow. So if we take AC, let me change the marker. If we take AC, let's clean this off. So we have x1, y1, x2, y2. So if we take the x coordinates, we have -1 minus 2 squared plus -3 minus 5 squared. So when we point this on the calculator, we are going to get 9. And if we point this one to, we are going to get 4. So if we add, we are going to get square root of 13 in a very simple way. Kindly use your calculator to point. Okay, so this one will be 4 plus 9, and we have this. Okay, now for these points to form the vertices of a right angle triangle, you see that this is the highest one, 65. This is 52, and this is 13. From Pythagoras theorem, then we have square root of 65 squared. Okay, let's use this. This is the highest. So the highest one is AB. AB squared should be equal to any of them. Either the small one or the bigger one can come. BC squared plus, this is AC. Please note this. Here I wrote AC. You can do it CA, the same thing. Here you can do it CB, the same thing. Here you can do it BA, the same thing. So let's check if this is true for a right-angled triangle. We have 65 under the square root squared. Is it equal to square root of 52 squared plus square root of 13 squared? This is 65 equal to 52 plus 13. We have 65 equals 65. Hence, the vertices form, the points form the vertices of a right-angled triangle. So this is one way to prove that. Let's see the other way. That is the short one or the simplest one. So I didn't conclude. You conclude that since AB squared equals BC squared plus AC squared, the points form the vertices of a right-angled triangle. That should be your conclusion, right? In a very simple way. Remember, it is the highest square equal to the other one's square, and then you sum them together. The alternative method is to find the gradient of the lines forming the triangle. So let's see. Now, we are finding the gradient of line AB, then gradient of line BC, then gradient of line CA. Remember, we can write this one as BA, this one as CB, and this one as AC. If we interchange the position, the gradient is the same. Now, how do we find gradient of a given line? If you have points, let's say A, x1, comma, y1, and point B, x2, comma, y2, then the gradient of the line joining AB is given by y1 minus y2 divided by x1 minus x2, or y2 minus y1 divided by x2 minus x1. So that's how we find the gradient of the line joining 2 points. Now, from what we have A to be minus 1 minus 3, B to be 6, 1, and then, okay, let's group them. We have AB. Then if you come to BC, we have B to be 6, 1, C to be 2 minus 5. If you come to AC or CA, we have C to be 2 minus 5, and A to be negative 1, negative 3. So I name here x1, y1, x2, y2 for the gradient of AB. So for the gradient of AB, I'll take this. Either I'll use here or here. So I'm using the first one. And these are y1, y2. So I'll take minus 3 minus 1 divided by minus 1 minus 6. And this is positive 4 on 7. Then if I come to BC, x1, y1, x2, y2. These are the x values. 1 minus minus 5 divided by 6 minus 2. So this will give me 6 divided by 4, which is equal to 3 out of 2. If I come here, x1, y1, x2, y2. So I have minus 5 minus minus 3 divided by 2 minus minus 1. And this will give me negative 3 on, sorry, negative 2 on 3 in a very simple way. Wow. Now, we can draw our conclusion. So here you see that, look at something. If I take the gradient BC, is 3 out of 2. If I take the gradient CA, it is minus 2 out of 3. Look at this. If I take negative 1 and divide by this, 3 on 2, point this on the calculator, you are going to get negative 2 on 3. Or, if I take negative 1 and divide by negative 2 on 3, if you point this on the calculator, you are going to get 3 out of 2. So it means that BC is negative reciprocal of CA, or CA is negative reciprocal of BC in a very simple way. So let's go and conclude. We write that since line BC, since the gradient of line BC is negative reciprocal of the gradient of line CA, line BC and line CA meet at right angles. I said what? Meet at right angles. Or we can say that since the gradient of line BC is negative reciprocal of the gradient of line CA, line BC and line CA are perpendicular to each other. Hence, the points A, B, and C form the vertices of a right angle triangle in a very simple way. So if I'm to draw the triangle will look like this. I'll put here 90, or I can draw it like this and put here 90. We have C, B, A. The angle should be here because BC, C, CA, or AC, it should be here. Or if I draw it this way, I'll put A here, C here, and B here. AC or CA, BC. You see that these two lines meet at right angles here in a very simple way. So this is the alternative method for the question. Thank you for watching. Please like, share, subscribe, and leave your comments.